Hello, and welcome to my Safer Sim webinar on dissecting the safety benefits of protected intersection design features. This was my master's project thesis for my degree in transportation engineering working on this project under Professor Christofa and Michael Nodler of UMass-Amherst, as well as assisted by Katerina, a fellow graduate student. And so to jump into the presentation here, let's go. So we wanted to look at the safety aspects of protected intersections for all users. There's approximately 50,000 cyclist injuries that happen a year on US roadways, and in addition to those injuries, 750 deaths. And cities, towns, departments of transportation, they're all looking at how to improve the safety and protected elements of roadways so that cyclists feel safer and more secure while navigating next to vehicles in urban and suburban environments. So a little bit about protected intersections. They're typically characterized by the presence of curb extensions with bulb outs. One primary example of these types of intersections are Dutch intersections, which are prevalent in the Netherlands and have been slowly been adopted in some US cities. These intersections are highlighted by protected access points to and from the intersection for cyclists, sometimes with their own separated phasing patterns, as well as their own light signals to accompany their movements. Sometimes they can be highlighted by different kinds of pavement markings as well to denote to other road users where the cyclists will be when they cross. And sometimes those are before or behind an already existing crosswalk. This is just another example of a protected intersection highlighting the different elements of safety that could be addressed. So you have a different level of bicycle marking with the green and the dashed white. You have capacity to hold a car at point number 1. As the car is turning right, there's space for it to wait without encroaching on the space designated to the cyclist. And it can incorporate other types of medians and sidewalk buffers as necessary. And so this project focused on developing guidelines for protected infrastructure elements, specifically looking at increasing the yielding pattern and behavior of motorists to cyclists through changes in the design of the intersection by the size of the intersection turning radius and the type of the pavement marking that was used. And so in the US, there's not a lot of literature comparing protected versus unprotected intersections, and there's no specific guidelines on how large or how wide your pavement marking should be if you're trying to create protected cyclist infrastructure. And so this project looked at the effect that changes in protected intersection radius have on driver behavior while they're making a right turn through a protected intersection, and then also what effect does level of pavement marking for the cyclist have on driver behavior while performing right turning movements as well. And so our experimental design consisted of a driving simulator study where each participant was asked to drive 12 separate drives. And then after completion of those drives, they were asked to fill out a brief questionnaire recording demographic data and cycling frequency to understand how prevalent or how accustomed they were to different protected elements and how safe they felt as cyclists. And so our experimental design focused on 2 different sizes of radii. We had a large turning radius, which is the image on the left, which was approximately, I want to say 9 meters, or yeah. The size of the turning radius varied between large and small, And this was done to illustrate whether or not a larger storage capacity for a vehicle increased or decreased the driver's speed as they were performing a right turn movement through the intersection. And we focused, and then the next level of variables was on the level of pavement marking that the driver experienced at an approach to each of the different protected intersections. And so each intersection had 6 different combinations, or there were 6 different combinations of intersection radii and pavement marking that drivers were asked to drive through during the experiment. And it was focused with just your standard intersection with protected islands with no additional level of marking, a dashed white marking, and then a solid green marking with accompanying the dashed white marking was the highest level of pavement marking that we chose to analyze for this experiment. And so our experimental design, if you put yourself behind the wheel of the driving simulator here, I'm just realizing my arrow is going to be backwards. But if you were to, we incorporated both right and left-hand turns in our study to, one, prevent simulator sickness and mix up the drives so drivers weren't to mask which variables we were necessarily looking to analyze. And so if you're a driver and you're approaching this intersection from the south and you want to turn left, then you're going to be following the path of this red arrow. And as you begin to approach the intersection from the south, a bicyclist would be started at the green arrow and cross the path of the intersection in front of you. And this same direction would be, this obviously would be flipped if you were turning right. The bicyclist would be crossing adjacent to you rather than on the opposite side of the traffic. But this was done to prompt users and see how they reacted to the presence of a cyclist in a protected intersection and to see what speed differences and behavioral differences were observed. And this is a list of the 12 different combinations that we had of experiments. So we had 3 different levels of bicycle marking, 2 different levels of turning radius, and half of the drives had a bicycle present and half of them did not, in order to measure what effect the bicyclist would have on drivers. And so for the right-hand start position, drivers would start at the box on the left. They'd drive through the first intersection and make a right turn, and they either would or would not encounter a cyclist crossing the path of the right turning movement that they were performing. And then they'd drive, they'd have a straight segment, and then they'd perform a left turn at the second intersection they approached. And if they encountered a cyclist on the right turn, there would also be a cyclist on the left turn. But if there was no cyclist on the right turn, there'd be no cyclist on the left turn. And then they would end the experiment. And then we reversed the direction of the turns. So instead of going right first, we had the driver turn left and then right. Same thing with the cyclist. There may or may not be a cyclist present at both crossing paths of the intersection. This effect was randomized to, again, discern if drivers were always looking for a cyclist or if they, got lazy or didn't recognize that there was a cyclist, but then had to brake suddenly because the cyclist was there. We collected 3 different sets of data markers. So we wanted to look at the approach speed of drivers as they approach the protected intersection to see if the level of marking and the way that the curb was shaped, if that influenced their speed. And then we also measured their speed as they were turning through the intersection to see what the speed was like as they started the turn. And then once they saw the bicyclist, did they come to a complete stop, or did they just slow down to a slow enough speed where the bicyclist could cross and then they could go immediately after. We included exit speed markers as well, but we did not include that data in this analysis because most of the drivers they accelerated very quickly after exiting the curve because it had a long straightaway, and the data wasn't as useful and also wasn't influenced by the protected intersections. And so our independent variables are listed here. We had, as mentioned previously, the turning radius of the intersection, the bicyclist present or not, the pavement markings, and then gender and age, which were two variables, participant gender and age. We tried to get an even split of male and female. And our participants, we ended up with 17 female and 19 male. And their average age was about 25. Given the student population of the university, this was what we were hoping to get. Something split into more age categories probably would have been a little bit better data-wise. But in total, we collected a total of 432 right turns from these 36 participants for the ensuing analysis. And what we found is presented in these violin graphs, and that participants' approach speed on approach to protected intersections was generally higher than what their speed was while turning through the intersection, which is something that we would hope. Their speeds were slightly lower based on whether or not a cyclist was present. And we performed 16 different tests to determine whether the observed speed differences were statistically significant. And our t-test showed that the approach and turn speed with and without a bicyclist in relation to the participant behavior, the presence of the cyclist was a statistically significant variable. And then we got into looking at the turning radius. And these graphs kind of mirror the first set of graphs with the bicyclists. And what we found is that the approach speed was not statistically significant, but the turning speed was. And I wish I had the, let's see. And so as you can see here with the next level of analysis that was conducted, we did it with the level of pavement markings for both the large and the small radius, this is actually with the approach speed and the turning speed. And as you can see, the intersection speeds are consistently lower, and the approach speeds are consistently higher and more elongated, showing a greater range of speed differences between participants. And our final, and we also did a t-test for this one, and we found that the pavement markings had a significant effect on driver behavior on the approach speed, but interestingly, and not on the participant's turning speed. And taking all this data, we performed a regression analysis to determine, to see all the variables together, which one had the most influence on driver speed throughout the intersection. And the only variable that came away as statistically significant after this was the presence of a cyclist. And the best fit line for all these variables was not as great as one would like it to be, suggesting that there is possibly something else going on with regards to driver speed. Around the turn, we have 5 out of 7 variables as significant, or 5 out of 6. Sorry for that. And the line of best fit goes up in terms of the R-squared value, which is generally a good thing and suggests that the confluence of these independent variables in the protected intersection can have a statistically significant effect on the driver's speed while navigating a protected intersection. And removing non-significant independent variables did not seem to have any impact on the results, and actually worsened the model's fit. And so our findings from our 432 right turns is that the presence of a cyclist had a larger, more persistent impact on participant speeds than any other variable examined in this experiment. This was anticipated as the scenarios were such that participants could easily detect when approaching or completing the turn and never failed to stop or yield appropriately to the cyclist. The presence of a cyclist caused drivers to approach the intersection at a lower speed, thus resulting in a lower turning speed. And the smaller radii resulted in higher speeds due to the presence of larger curb extensions and corner islands that seem to be slowing vehicles down while performing their turns. And interestingly, the intersection crossing pavement markings only seem to affect the approach speed of motorists while navigating the protected intersection, and the turning speeds of all participants was significantly affected by the size of the turning radius, the presence of a cyclist, how frequently they cycled, which is information that was collected from the demographic data, as well as participants' age and gender. From that perspective, the inclusion, age, and gender, and whether the inclusion of the last three variables on the screen there improved the regression's goodness of fit, and this suggests that there are additional demographic and background factors that affect the participant speeds at protected intersections. Interestingly, older drivers chose lower speeds at turns, while female drivers and participants who reported being bicyclists chose higher speeds while turning at a protected intersection. And so moving forward, there are multiple design elements of protected intersections that could be explored to measure the effectiveness of different treatment levels on the safety of protected intersections. In addition to intersection radii and crossing pavement markings, signage types, crosswalk position, and different levels of signalization could be studied to assess their effectiveness in improving safety at protected intersections. These variables could be explored on their own or in conjunction with previously tested variables to formulate a better understanding of what the ideal protected intersection should look like. And that concludes my presentation on dissecting the safety benefits of protected intersections, and I will open it up to questions.
All right, so Nick, the question came in. Did you ask participants after the session if they had any reactions or impressions regarding the various conditions? Just curious if they shared any added insight.
Yeah, part of the debriefing process for this experiment was to ask participants what they thought was being measured. And a lot of them actually thought it was just purely a bicyclist study and whether or not we were looking to see how they interacted with cyclists. A lot of the drivers, from my recollection, mentioned that they didn't necessarily realize that the radius of the intersection was changing. But they did pick up on the changing level of pavement markings, but they did not realize that the size of the turn they were being asked to perform was significantly different.
Nick, in the scenarios, was there any traffic? I'm thinking, for those left turns that might have affected the speed that they were crossing, or their turning speed.
Yeah, no, the short answer is I did not include ambient traffic. So it was just the driver in an urban environment and going through two turns, and they either did or did not encounter a cyclist on both turns.
Okay, thanks. All right, we do have another attendee typing, so we'll give that a few seconds here. I do want to thank everyone for their time and their interest in our Safer Sim work. So this presentation will be available online on the Safer YouTube page and our website by the end of the week. We'll also share that with all the registrants, so feel free to share that with any colleagues that may be interested. Okay, that question came in. Where was the bicyclist positioned?
So I'll bring it up on the screen here. So the bicyclist, if there was one, it was prompted to start along, I don't know if my cursor shows up, but basically right where the arrow for the right turn box is where the first cyclist was, and then if you flip that position for the left turn, the cyclist would start along the parallel or the same. They'd start on the opposite sidewalk of the driver, going in the opposite direction, so that the cyclist was always crossing the path of the participant.
And we still do have some more typing. I will get one more pitch in for our next webinar, so keep an eye out for future announcements. Our next presentation will be on September 10th. That will be a Tuesday, and it'll be at the same time. That presentation will feature work from the University of Wisconsin-Madison, so we hope to see everyone there. And we did get this question come in. Did the drivers see participants from the distance? So, like, were they able to see the bicyclist starting, or did they have an obstructed view?
Along the so because this was an urban environment, we had parked cars along the sidewalks, so the cyclist was obscured from view until the driver got to the intersection, and then the cyclist started to cross as they began their turn.
Okay, I am not seeing any more typing. So once again, thanks everyone for joining. We will be sending the recording of this out to the registrants. So feel free to share that, and we hope to see you at our next one on September 10th. Thank you.